Morning. Welcome to today's presentation, Cloud Security Assessment for AWS Instances, Securing AWS with Chef Effortless Infrastructure Suite. Let's go ahead and get started. Nick, over to you.
Thanks, Aaron. And everyone, you get to have a front row seat for a bit of a live change from me since I had a deployment snafu real quick. Always fun on demo day. Thankfully, though, I think I'm just about to get myself back into a good state. So bear with me one moment and we'll get this show on the road. Let's see here. While we're kicking things off as well, I will call folks' attention to the Q&A area. We will be monitoring for questions throughout the demo, so definitely be sure and get your questions in, and as we wrap things up, we'll be looking to address those. And it looks like we're just moments away from getting things back on track. So thanks again, everyone, for your patience. Nothing like a good old last-minute demo day hustle. While that's getting ready to rock and roll, we'll kick things off by letting folks see where we're going to be diving in today. So a couple of weeks ago, we did a webinar talking about some cloud security challenges. And today we're going to cover some very similar content, but with more of a deep dive focus on what it is Chef's tools are doing and how you can start evaluating your cloud environments. One of the things we'll be taking a look at is what you see here is some data from RightScale's 2019 State of the Cloud report, where they end up talking to a number of organizations, figuring out where they are in their cloud implementations, and as we see here, what challenges they're facing as they move into the cloud and mature their practices there. And one of the things I noticed right off the bat, and you can see highlighted here, is that the two categories with the highest number of respondents that replied that they have significant challenges were lack of resources and expertise and security. I found this interesting, especially in light of some of the things we were talking about in our last webinar. And in particular, where the rubber meets the road here is folks having anxiety about how they secure the resources that are new to them within their cloud estate. Even though the problems that are being solved aren't unique to cloud or on-premises deployments, doing things in the cloud means learning a new set of tools and practices. And that brings us to the shared responsibility model. So we've talked about this quite a bit at Chef, and this graphic comes courtesy of AWS. But at a high level, what the shared responsibility model is a delineation of who is responsible for what within a cloud platform. The way that AWS is breaking it down here is that they, as the cloud provider, are responsible for the security of the cloud, providing resources that are themselves inherently secured and can be securely created and configured. As a customer, you are responsible for security within the cloud. And in some places, this is pretty obvious. For example, when we talk about operating system configurations, that's something that pretty much everyone's already doing in their on-premises or virtualized workloads and seems natural to do whatever environment they're working in. Some aspects, however, things like network and access configuration, identity management, have analogs in the cloud to the tools and systems that organizations are using within their own data centers, but the specifics of how those tools are used change. So ultimately, where we have that overlap between the lack of maturity and expertise in cloud practices and lack in practices around security, those problems end up getting exacerbated here, where we not only need to learn how to use our new cloud-provided tools, but also how to validate that we're using them securely. Another thing that leaps out to me in this report is security and compliance are right next to each other with near identical responses. And this isn't a huge surprise to me either. While the specifics of handling security and compliance might have some differences, there's a whole lot of overlap. And in particular, if you're an organization that's seeing challenges with compliance, I'd be surprised to learn that you're not also having challenges with security. So it's not surprising to me to see these tied together. And in particular, for organizations that are seeing compliance challenges, a lot of that comes down to the pain around compliance audits. And for a lot of organizations, compliance audits can be very painful. They can be time-consuming, consist of a lot of manual processes, and end up requiring a lot of post-audit work to remediate any issues found. So why is that? Why are compliance audits so painful, and do they need to be? Well, a big part of this, excuse me for a second while I do some work behind the curtains, multitasking Nick Rycar. All right, part of this is that a lot of organizations are just doing periodic audits, which often don't tell the whole story. If you look at sort of the comparative graphs here, if we are, say, auditing ourselves 4 times a year, we can draw a line between where we performed on those audits and have sort of an assumed level of where our compliance was in between. But in actuality, things tend to look a little bit more like what we see on the right here. And we see this validated with a lot of our conversations with our customers, as well as what we see in sort of analyst reviews and reports that have been published year over year. Whenever you stop looking at your compliance posture is when it's going to start to dip. If you did an audit yesterday and a new code release went out today, guess what? You no longer know your audit posture unless you're doing things more frequently than every time an auditor comes to call. Now, even for folks that are doing more frequent auditing, often those audits are only happening within pre-prod or production environments. And that security review process is often manual. It generates a lot of false data for systems that, say, have exceptions or extra defensive depth strategies being taken that need to be parsed through to validate whether or not an issue uncovered is actually an issue that needs to be addressed. And by saving the security review until after a meaty part of the development cycle has completed, anything that we catch at this point is going to be costly for us to fix, since we have to go through the entire development cycle one more time with whatever remediation we come up with. And as I sort of teased earlier, this is a process that doesn't tend to handle exceptions very well. So even if we are using a sort of predefined format to review our security, we aren't necessarily able to easily capture where in our environment a security failure in our utilities is actually not a security issue for us in practice, because we're taking additional compensating efforts to address. So you throw all these things together and you have an already painful audit process that gets made more painful by saving our security review until far too late in the process. Finally, we have the issue where different teams are often speaking different languages. And so you might have compliance professionals that are working with the guidelines of whatever regulator or regulators your organization is beholden to. You have security professionals that are using maybe a combination of scanning utilities and scripts to evaluate systems, and DevOps and IT professionals that are responsible for the day-to-day operations of those systems. So these communication issues are not just at the high levels in the companies, they're also prevalent in how we talk about compliance generally. And this can lead to many us versus them conversations between our IT staff and our security engineers and our auditors and compliance officers. The IT staff are the folks that know the most about the systems and applications being managed, but the least about the compliance requirements that the organization is beholden to. The security engineers know the standards, but not necessarily the technology. So they're often looking at penetration testing and vulnerabilities in the abstract sense, rather than as it relates to the specific makeup of applications and environments. For our compliance auditors, we just want to make sure that we're passing. The lights turn green in whatever tooling we're using to validate, and understand the regulatory requirements, which are often published as high-level posture, but don't know sort of how it translates to the low-level work that needs to be done to specifically address whatever gets uncovered. So Ultimately, this is all exacerbated by the fact that existing tools are often need to be translated between these teams. You might have PDFs, Word documents, Excel spreadsheets on the compliance side of the site, the fence, security teams using a variety of scanning and vulnerability testing utilities, and development and operations professionals using all manner of software, both to create, configure, and monitor systems. So ultimately, the way to address this is to manage compliance as code. Turn our requirements into something that can be automatically run against any of our environments, so that whether or not I am a subject matter expert of any specific standard, I can run that code and see whether what I am responsible for is in compliance with that. This enables us to better scale across systems. As we codify those requirements, we can apply them across the board to any systems that need to meet them. It makes shifting our compliance and security left much easier because, again, in development, in staging, in QA, whoever's responsible for taking a deployment to the next step of a pipeline or workflow does not need to be an expert with the security frameworks as a whole. They simply need a way to execute those frameworks as defined in code. This also allows us to keep continuous visibility into our systems. So in this case, we're looking at Chef Inspect code, which can be run on a regular interval and have its data sent to Chef Automate, a visualization dashboard for those compliance scans. And we can take a look at not only the real-time status of all of our systems, but the status over time, so that as we move from audit to audit, we know how our posture has changed, whether any new changes have increased our security risk, and to what extent that risk was disseminated throughout our environments, and of course, finally, how and when that risk was discovered, remediated, and fixed, ultimately. We'll also have a way to collaborate. So Inspect code is designed to be easy to read by just about everyone. We have an example here on the right that is looking to see that if we're using a tool called SSH, that we're setting the version to 2. And in the actual code itself, where you see describe SSHD config, all we're doing is a simple matching protocol. So within Inspect, what we're defining are expectations. In this case, we expect the protocol of my SSH config to compare against 2. I don't want any SSH1 in my environments. So we have something that is easy to read for everybody, easy to write for the folks responsible for environments, and then ultimately something that can be run consistently wherever we have to scan and audit our systems. So if we take a look back at the shared responsibility model, this is another place where codifying our compliance requirements reaps us very large benefits. Particularly when we talk about evaluating cloud environments, we find ourselves often in a tool sprawl scenario where we need to use fundamentally different tooling to evaluate our cloud native resources than what we're using to evaluate our traditional server and VM resources. With Inspect, this doesn't need to be the case. Chef Inspect allows us both to evaluate traditional Linux, Windows, and Mac OS systems, as well as providing API integrations with the major cloud providers, so that we have the ability to scan our AWS estate and look at the status of things like compute, our VMs themselves as objects, storage, our S3 buckets and the like, databases, all of our cloud-based database services, and of course, networking, IAM, security groups, the works. And so with that, today in our demo, we're going to be taking a look at the tool provided by Chef's Effortless Infrastructure Suite. This includes Chef Automate, which provides us with consolidated filterable dashboards to drive our observability. We have Chef Inspect, which provides us with, the Effortless Infrastructure Suite additionally provides us with some pre-built profiles based on the Center for Internet Security's benchmarks. This includes profiles that have been certified by CIS for our cloud providers, including AWS. We have Chef Infra, which is a tool that we can use to configure our infrastructure and cloud resources and ultimately remediate any issues that we uncover with Chef Inspect. And finally, we have the means to integrate with third-party utilities. Here we're looking at requirements for provisioning and creating images, which in the cases of my demo, I'm using Terraform and Packer respectively, which each integrate with Chef so that we're able to make use of both the cloud integrations that these third-party tools provide, as well as those provided by Chef itself. This is a good time for me to take a peek and see how my environment is doing. And it looks like this may be a new record for me as far as having to completely reset my demo environment at the last minute. But I do believe I'm there. So I'm going to quickly validate that. While I'm doing that, Alan, do we have any good questions coming in from the audience so far?
Let's check here. I think so. Let me double check here. Can Chef Inspect be used in tandem with a cloud provisioning tool like AWS Cloud Formation or HashiCorp Terraform?
Yeah, so that's actually a great segue since we were just calling that out. So I mentioned some integrations with Chef and those tools, and traditionally that's been limited to things like Chef Infra or Chef Habitat, which we're not diving into much today. But it also has some nice integrations with Chef Inspect. In particular, there's a tool called Inspect Iggy, which can actually take state files from both CloudFormation and Terraform and translate those into auto-generated compliance profiles with Inspect. So it's a great way to sort of take what is known to be the canonical running environment and build out a set of Inspect rules from that without needing to sort of go resource by resource and build that out by hand. So that can be a great time saver, especially for folks that are just starting to dip their toe into the water and aren't sure what things they need to create scan or controls for. That can be a great way to sort of kick things up and start getting value right off the bat. Here we go. So it looks like I've got my new environment up. So that's great. I'm doing some stuff in the background here since I love you all, but I don't want to show you any of my private keys, certainly on a recorded webinar. But we'll have that done in just a moment. And to tease you out while we're doing that, the next thing is going to be a demo. And we're going to dive right into the Chef Automate dashboard, see how we can look at the security and compliance data provided by Chef Inspect, as well as some of those pre-built resources that come packaged with Automate that we might want to use. So I've got 2 more secrets to copy before I can screen share. So I'm going to go on mute for just a moment. And while I am doing that, Alan, let me know if there are any other questions coming in. And for all you in the audience, this is a great time to ask one or two. I'm back in just
I was going to say, if you have any questions, please put it on the Q&A tab, which is a great way for us to engage there. One question I usually have, Nick, around this and is the beauty of our Effortless Infrastructure Suite, as you mentioned earlier, is kind of the integration of the tools, and it's more than just assessing the shortfalls that Inspect can provide, right? What's the beauty of having, Chef Infra and Chef Inspect work in tandem?
Well, since both of them are sort of translating what we need to do into code, everything that we are detecting with Inspect becomes something that we can then correct with Chef. And so we're not only getting feedback onto whether or not our systems are configured correctly, but we have actionable insights that come from any failure, where we can have a relationship between those Inspect resources that are validating things and the Chef resources that will then need to correct them. And so ultimately, you end up having a single place to do all the things you need to do. And with Chef Automate, it's aggregating those Chef Infra runs as well as the Chef Inspect scans so that you can see the full history of everything that's changing in your environment in one place. And it sort of lends itself to a continuous pattern, something that if you've seen me do webinars and demos before, you've probably heard me talk about the detect, correct, automate loop, where before we can do anything, we need to know the target that we're trying to hit. So detecting things with Inspect ends up being where I advise folks to start, because without knowing what you need to solve, it's hard to know what things to automate. Then, because Inspect isn't actually making any changes, we can run it pretty broadly. Since there's not really any risk associated with running an Inspect scan. We're just collecting data and reporting back about what's been found. Excuse me while I type stuff. I guess I can't walk and chew bubblegum. There we go. Integration saved, and I think I'm done killing time with secrets, but let me finish up that thought, since I think that's a really great place to live. So ultimately, what we end up having at the end of the day is a single set of tools to manage discovering issues, fixing those issues, and automating the process of doing both. Because as we can kind of see from that audit cycle where things drop off fairly quickly if you're not managing audits continuously, and I'll go back to that slide for the visual aid, this is really the key benefit right off the bat of having that continuous way of doing things. Because having to find and solve a problem can be difficult. Having to resolve a problem that you already thought you solved previously is just the worst. So being able to automate both of those processes means that things stay fixed when you fix them. And you can go on to do truly new things with your time and build out whatever innovations are going to get your organization ahead in whatever it is you're looking to deliver to your customers. And so
there's one question before you go on, and I think it revolves around Chef Infra. So I think it's kind of cool for us to insert that there. So as you're describing all of these three, different products and how the suite works, and is Chef Infra an orchestration tool as well, or only the configuration component?
Oh boy, that's a tough one. Like, really, the short answer is it's not. So it really is, Chef Infra is specifically concerning itself with configuration management. Now, the reason I sort of hesitate before saying that definitively is that there are a lot of things that Chef does that, if you're not doing automation already, might feel like they live in kind of more of an orchestration world. And while we're not covering it today, that, to my mind, is doubly true of something like Chef Habitat. But with Chef Infra, for example, we have the ability to sort of evaluate our surroundings when we're applying configuration and do so dynamically. A good example of that is, and this is something that we see a lot when, development environments are not identical to what's ultimately going to run in prod, and oftentimes they aren't. We don't have to create and maintain environment-specific configuration resources, however. Because we have the ability to say, evaluate our local running system and see how much memory and CPU we have to work with, for example, we can apply things like configuration tunings for our applications, web servers, et cetera, dynamically as informed by those values rather than statically where we might need to change them from environment to environment. And we even have sort of a middle ground where you have the ability to define what in Chef Infra are called attributes that are essentially variables that you as an end user can set without having to change any of the underlying code that you're applying. So in the sense that, you have to be able to manage the deltas between configurations and environments, there's a lot of ways to do that in a more dynamic and programmatic fashion than traditional bash scripts and the like might give you the ability to do. But it's also something where, orchestration is not a fundamental part of what Chef Infra is doing. So ultimately, it folds into any further orchestration that needs to be done. So if we're, say, like doing on-demand provisioning as part of a run through a pipeline, we might be using other tools to both instantiate a pipeline and handle our environment provisioning. But within those processes, Chef becomes the way, or Chef Infra in this case, becomes the way that we actually apply configurations to those environments. And similarly, Chef Inspect can become the way that we validate whether we have met our requirements for a particular stage of the pipeline, say. So you would have automated tests that, similar to how compliance scans would let us know whether or not we are within compliance with our regulations, a scan during a pipeline might tell us whether we are in line with our organizational requirements for promoting code. Oftentimes, there's going to be overlap. Again, you want to make sure that you're evaluating those formal compliance pieces as often as possible. But because Inspec is just an engine for checking an environment against expectations, it can be used to solve a broader array of security and testing needs throughout that process. So, bit of a long-winded answer, but it's definitely something near and dear to my heart.
Cool, thanks. Off to the demos now.
Off to the demos now. So, beautiful thing here is that most of what I'm demoing is stuff that comes right out of the box with Chef Automate. So even though spinning up a new environment means you don't have the pretty scans that I did ahead of the demo, we're going to be creating some new ones as we go. So nothing lost for us. We're going to kick things off. Oh, I have way too many windows open here. Let's take a look there. What happens when I'm furiously running through a new environment creation. What I have sitting in my local environment, however, is my AWS profile. So this is an Chef Inspect profile that I've created to do some simple validations against my cloud estate. This is where we'll start and sort of introduce you to some of the resources available and what kinds of things Chef Inspect can do to evaluate our cloud instances. Here in Visual Studio Code, we have the contents of that profile. And within a Chef Inspect profile, we have controls, which make up the actual validations we're doing. So if we look at my iam.rb control here, we have in every control a title here. So we're checking my user in Amazon. A nice human readable description. I want to make sure that my user exists and that I'm using multi-factor authentication. We can define an impact. This is how severe this control is if it fails. It's on a range from 0 to 1, which will put things in minor, major, or critical categories. And finally, we have the actual Chef Inspect code. Here, we're using the AWS IAM user resource provided by Inspect's AWS Service Pack. And I'm specifically looking for a user with the username and Rycar, my user. And then we define with what are called matchers our expectations. My user should have S3 buckets. So this is our storage buckets in AWS. And I have a couple in specific that I'm checking. One is designed to be a public bucket. So this might be where I store some public-facing data in a way that's easy to grab. Again, I'm defining my matchers here. It should exist. It should be public, and it lives in the US West 2 region, so I want to evaluate that as well. And then I have a similarly named private bucket. Same exact thing, except this bucket should not be set up for public access. So the control looks very similar. However, what we are evaluating here is that it should not be public, where the other one should be public. And that's it. So 3 controls here that I can evaluate from first the command line with the Inspect command line utility provided by Chef Workstation, which has all of our sort of local development and configuration tools packed in. So I'm going to run inspect exec to execute this profile. I'm going to define my transport as AWS, since we can do this over SSH, over WinRM, or if we're talking about cloud providers, a transport for each of their respective APIs. Then I'm just going to use the, what was it called, my AWS profile that's sitting here, and we'll get the results back in our terminal. So this is great for an ad hoc check. And indeed, I can see some things are passing, but I do have a failure. My private bucket's expectation was that it not be public, and it looks like that expectation has failed. You'll note here that within each control, I define multiple matchers. And while in this control, some of my matchers succeeded, the bucket does exist and is in the right region, the control as a whole will fail if any of its parts fail. And here, it looks like that bucket is not private as I expect it to be. So I'm going to hop into my AWS console. I'm going to go into my S3 here, and we're going to look for my Chef buckets that are being evaluated in the scans. It looks like my private bucket is indeed public, which I don't want it to be. So here, let's just go ahead and do a quick by-hand remediation just through the AWS UI here. Within our buckets, we can access their permissions. We can do it via an access control list, but it does have a nice handy block all public access option right here at the top. So I'm just going to go ahead and do this because I don't want anyone who's not in my organization to have access to this. I go ahead and confirm that change. And then I'm able to come in here, rerun my profile, and see if we have actually solved the issue that we uncovered. And indeed, now we come back with a clean bill of health from my demo profile. So far, so good. But if we want to get a little bit more involved with what we're scanning, obviously in a real world environment, my needs are going to be a little bit more than just a couple of resources. To that end, we provide a variety of pre-created profiles, both of some generalized baselines and some formal ones. You'll see a lot of these CIS benchmarks, which are provided by the Center for Internet Security and can be used to help solve a variety of compliance needs. CIS also publishes a list of compliance frameworks and how their benchmarks relate so that you can get a good idea of the coverage this provides for whatever your audit requirements are. We also have DISA STIGs available for things like Windows and Red Hat Enterprise Linux, as well as the first profile we're going to use here, which are the CIS AWS foundations. So these are not for a specific operating system, but for the Amazon cloud itself, and provides a list of best practices that we can use to get a jump start on discovering whether or not our cloud is secured properly. So we have our profile ready. The next thing I need to do is create a scan job. So this was what I was doing in the background when I was talking about all my secrets copying here. I was setting up some integrations that we'll look at in more detail shortly. But to kick things off, I have this AWS API integration that I can use to scan my AWS environment. I'm going to limit my scan to the region I'm working in right now, which is US West 2. And in the next step, I can pick which profile I'd like to run in that environment. And I'm going to go ahead and run that CIS AWS Foundations benchmark I just downloaded. And finally, we can set up a schedule. In this case, I'm just going to do a one-time scan, but we can set things up for recurring runs or scheduled runs, as well as recurring runs if we would like it to repeat for a particular interval, and define an end date if we want to have something that runs within a particular time box schedule. If I uncheck this, though, it's just going to do a single scan right when I create it. So you'll see that now it went automatically to scheduled and running, and should complete evaluating our environment shortly. While we're waiting on that, we also have some profiles available for a variety of operating systems. And I actually have some applications running that are running on CentOS 7. So I'm going to go ahead and grab the server benchmarks for CentOS Linux 7. Again, by grabbing get, I can grab it and make it available within my Automate server so that I can create a scan job for that as well. Now, when it comes to evaluating EC2 instances in AWS, there are a number of ways we can do things. We can do things directly by IP address, or if we're configuring things with Chef Infra, can run inspect scans as part of our run. In this case, though, we actually have an integration with AWS that lets me define which EC2 instances I would like to scan, both filtered by their region. And in this case, I'm going to filter by a couple of tags. Mine are running an application called National Parks, and I only want to use the ones that are mine because I don't have SSH keys for any of my colleagues' environments. So with these tag filters, I can make sure that I'm going to scan the right number of systems. And what's nice here is if I set this up as a recurrent scan and create new EC2 instances that match this tag filter, they will be incorporated into subsequent scans automatically. So this is a bit of a dynamic way to add instances to scan via the Chef Automate UI. In this case, as mentioned, these are running the CentOS 7 Linux benchmarks, or running CentOS 7, so I'll grab those benchmarks. And we'll go ahead and create a CentOS CIS scan job and save. All right, so while that is running, it looks like our AWS scan has completed, and we can take a look at the results of our scan. So here it looks like my environment is indeed not compliant with the CIS benchmarks, because it'd be very boring in a demo if everything just worked right off the bat. And then we can actually dive into the profile status here to get a high-level breakdown of how many of the controls failed versus how many passed. And of the failed controls, what was their severity level? It looks like all of our failures were major failures. We can also dive into the details of that scan. So here we can take a look at the scan results control by control and filter by, say, which controls are failing by severity, and can even look at the details. So here's one that comes up a lot in my conversations. There's a control that requires we ensure no security groups allow ingress from 0000, which is just universal, on port 22, the port for SSH. Take a look here. We can see a little bit more details here. Security groups provide stateful filtering of ingress-egress network traffic, and it's recommended that we restrict this port from a global access role. We want to be very careful about who we grant privileges to that port on. And we can even see in the results a breakdown of which of my security groups passed and failed, so that I know exactly what needs to be remediated and what doesn't. From this same view, we can take a look at the source code as well. If we're looking to get some more insight into how Chef Inspect evaluated something to inform how we're going to remediate it, we can see exactly what was done. Here we iterated over every AWS security group that was found, and for each, we wanted to make sure it doesn't have a rule that allows in port 22 over a global access. Anyone can come in. We can also see some tagging here, so I can see which CIS rule is being covered here at a glance. If we come back into our reports, let's see whether, ooh, good. So now we see the results of that second scan we set up. This time around, we went and gave it a swath of machines that fit a tag filter in AWS, and I can get the results back machine by machine. And we can now even look at results profile by profile, so I can see if there were differences in how one environment, machine, et cetera, performed over another. I can view that here. And indeed, in the scan results, for example, I can see this first rule failed on all 7 of my systems, and can view them system by system, or back in the report, can go into the node view and just grab a particular node and how it performed. So again, same concept as before. We have these CIS benchmarks to help give us a solution to the blank canvas problem. If I can evaluate anything, where the heck do I start? Here we have an opinionated approach to how to solve for common security or compliance issues, and some actionable items that come out of an out-of-the-box scan. So while it's never fun when your environment needs to get recreated right before a demo starts, it does at least speak to just how quickly you can get up and running with Chef Automate, since everything we're seeing today is right out of the box. With that, I'm going to stop my screen share. We're going to come back into the slide deck for a bit of review, and then we'll run through the remainder of questions as we have time. So we have a number of examples of how Chef Inspect can interact with a cloud provider beyond just scanning the instances you run in the cloud. And we can see examples here. We saw in my custom profile an IAM policy. This one's actually an example from those AWS foundations that iterate across the whole account. But again, we can make sure that we're securing our cloud access properly and view the results as a simple control summary, what passed, what failed, or with that Chef Inspect source code, so we can dig into the specifics of how things were evaluated and address individually as needed. We also can see an example of hardening some existing cloud resources. So we ran this scan and we took a look at which of our security groups are allowing access over port 22, and can even right out of the UI here see at a glance which of those groups are failing this rule, so that we can address and remediate accordingly. And of course, even in the cloud, we're still going to have servers running operating systems just as in our traditional data centers. So we have CIS benchmarks for Linux, Windows, Mac OS, AIX, all kinds of platforms that you can go grab and run today to see how you match up against those benchmarks, and whether or not you want to start taking action on any failures uncovered. And to put sort of a finer point on it, we've been seeing these benefits throughout our engagements with our customers. And ultimately, what we're able to do after implementing continuous audits with Chef Inspect and Chef Automate is that we can maintain both an up-to-date and a historical record of our compliance status, which allows us to both satisfy any scheduled audits that we have, as well as giving us the ability to run ad hoc audits on demand as they're required for any day-to-day operations. We're able to detect and correct security issues early before they reach production. Again, this is a key aspect of codifying your requirements so that you're able to apply a consistent set of evaluations into every environment and correct any issues before they've even gone into QA and staging and beyond. Ultimately, that allows us to sort of have our cake and eat it too. We want to deploy our applications faster. That's part of why we went into the cloud, so that we can spin things up and down on demand, scale, deploy, etc. But every time we deploy something new, there's a possibility that we are no longer in compliance with our requirements unless we're continuing to validate things. So by applying audits continuously, we're able to hit that speed and velocity that our customers demand of us, while still mitigating risk by making sure that no matter how frequently we release change, we are always validating whether those changes affect our security stature in any way. So as an example, we had a major healthcare services provider that we worked with, and they were able to reduce their audit cycle times by 95% by continuously detecting and remediating compliance efforts. Ultimately, it allows you to sort of address things as they come up, rather than having to scramble when audits come around, or having to, schedule an all hands on deck deploy day to cross those fingers and hope you don't have any problems to address. And if you do, you might have a large batch of them that need to be untangled at once.